So in science, we often have numbers that are really, really big or really small, and one convenient way of writing these is with scientific notation. So what scientific notation is always going to follow this form where we have all of the significant digits, and then we're going to multiply that by a factor of 10 that would get us back to the original number. So if we have an example here of 2007, I'm going to start right here where the decimal place is. I'm going to move it 1, 2, 3 so that I have the decimal place right after the first digit here. And then I'm going to write that out, 2.007 times 10 to the 3 because I had to move 3 times. If we had a larger number like this one, we're going to move it over 4 times, again, to the place right after the digit. I want my decimal place right after that first digit. And I'm going to write out all my significant digits. And this time I'm going to write it times 10 to the 4. Okay? Notice that when we took a big number and we made it a smaller number, we get a positive exponent up here. Now here we have 43.38, okay? It doesn't matter that this is already a decimal. I'll just go to where the decimal place is, right here. I'll move it over 1 so that it's right after the first one. I'll rewrite that 4.338, and this time I'll write times 10 to the 1. And you would put that 1 in there. You're typically never going to see a number expressed this way, because this is supposed to be for really big numbers or really small numbers. It's kind of impractical to do this at this scale. So you're typically just always going to see that 43.38. And there are different rules about when it would be appropriate to start doing scientific notation and whatnot. I don't really think there's a hard and fast rule, but this in particular would be kind of silly. Now, let's see if we started with a number smaller than 1. Like this guy, we got our decimal place right here. In this case, we're going to move it to the right this time. 1, 2, 3, so that the decimal place is right after my first significant digit. We're going to write out all the significant digits, 6.3, and this time we're going to go times 10 to the negative 3. Because we're taking a smaller number and we're making it bigger, we're going to have a negative exponent. Same here, where we have all of these insignificant digits, and then we're going to recognize that this is a significant digit. We're going to move on over until we have 8.60. Okay, we're going to retain all of our significant digits when we write that, times 10 to the negative 4 in this case. Similarly here, if I wrote this without any decimal place at all, well, this guy isn't significant now, right? So I'm going to move it the 1, 2, 3 places, put that decimal place right there, and I'm going to drop the 0 now. That guy's not significant. I don't need him. So this number becomes 1.08 times 10 to the 3 in this case. And if you're wondering about this form here, well, we can just double check that, right? We can take 1.8, we can multiply it by 10 to the 3. That's going to equal 1.8 times 1,000, because 10 to the 3 is 1,000. And if I do that math out, I get back to my original number, 1080. And I can see that this, in fact, does represent that number.